Okay, let's review. 3.6 billion years for life to get here, a moment in which we are sharing the planet with easily 8.7, 8.9 million species. We already know that humanity, through the history of humanity, we had taken biodiversity through 3 waves of extinction. Early on, where most of the large animals that were gone, we ate them. Then came the expansion of agriculture. That was the second wave of extinction. And now, with that push that we got from agriculture, the gross human population grew quite a lot, and now we are kind of posing the third wave of extinction on biodiversity as it relates again now with issues like climate change and things like that. We show that in the last decade, this last third wave of extinction is leading to declines of species everywhere around the world, many of these species going extinct. We also established that the scientific knowledge is pretty good to point out that the underlying reasons of this decline relates to things like overexploitation, habitat loss, climate change, the introduction of species, overconsumption of natural resources, and a lot of people that are being in the planet doing all of those things to begin with. We also showed that this is something that is obvious to many countries around the world, and many countries are very concerned, and they are doing the best they can to stop these losses. Unfortunately, we review many of these solutions, and every one of the solutions had shown that they are just not coping with the magnitude of the challenge. And we established in this class that perhaps the underlying reason why they are not succeeding is because all of these solutions are looking at the distal drivers, trying to fix the consequences of the problem rather than trying to fix the problem to begin with. Last lecture, we went over some of the ultimate solutions dealing with human overpopulation and some of the complexities as well of dealing with that. Today, I'm going to wrap up the entire lecture, and I want to give a different spin to the problem and make you realize that this problem actually originates from you and me. Rather than us thinking the governments are not doing, going back to the beginning of this problem, which is actually you and I, perhaps the ones that are not doing enough. And I want to finish up the class again, hopefully with the expectation. I'm going to end up with, hopefully with the expectation that you can reason so some of the consequences of the things that you and I do on this planet. So just so that I don't get anybody aggravated by this, I would like to use myself as an example on this lecture. And I'm going to start by looking at my environmental footprint in the planet. Keep in mind that I am a person that I do the best I can to have the smallest of impact on the planet. And even despite the fact that I'm conscious about this, I still had a quite a massive impact on this planet. And this is what I want to focus my attention in this last lecture. Let's start with my day, again, just for you to realize the reality on this. This is not something that we just don't know. This is something that we do every single day. Let's start with my day at 6:30 in the morning when I had my breakfast. And I like to have cornflakes. Easy and quick. Get your breakfast and whatever. Now, if we use cornflakes as an example, to produce these cornflakes, obviously you need land, and unfortunately that land was used back in the day for forests, and unfortunately for humanity to provide this cornflake that I had in my breakfast, and leading to the habitat loss on countries in Asia, North America, and South America. This massive expansion of industrial agriculture so that I can have my cornflakes. And there you can see already by 6:30 in the morning how me eating cornflakes is leading to habitat loss on different places around the world where that cornflake comes from. Now, the other problem with the industrial expansion of agriculture is the fact that we use a lot of nutrients to produce these crops, and that's leading to climate change. And there you have it. So already by 6:30 in the morning, my footprint on the planet has been significant enough, contributing to habitat loss and climate change. 6:30, I go and take my shower. For many years, as I explained to you, I was in love with this product called Dove. I don't use it anymore, but this was an example in which right there in this product that is right there on my bathroom, I was using a product that requires palm oil right there that is leading to the deforestation on many places around the world, and that deforestation is leading to the loss of species that depend on that forest. So there you have it. That's my contribution by 7:30 in the morning. Again, unfortunately, supplying this palm oil is being done in some of the most diverse places in the planet, in Africa, the South Pacific, and it's South America. This palm oil is being grown in my own country right there in Colombia, in South America. There are multiple case examples in which these companies that produce palm oil go into the forest, they displace the native people. The way that they do it in Colombia is by financing these terrorist groups that want to start shooting like nobody's business. People get scared and they run out of their lands, and then the companies go and buy the lands of the people that have been displaced for nothing. These companies go and cut the forest. There is no oversight from the government. And again, just for you to realize the consequence of something that I don't appreciate at all, but it was me, the one contributing to this problem. And again, here I'm now having an effect on habitat loss on a completely different set of countries, and that's just by 7:30 in the morning. In the morning, I get out of the house. I don't drive a car, but I'm going to assume here, for the sake of this example, that I drive a car. Now, obviously, you gotta put gasoline in this gas, and this gasoline is being supplied from many countries from around the world in the Middle East, the United States, and South America, and that obviously is a contribution to climate change, and that's just by 8 in the morning. Many of you could say, oh, you know what, I have become environmentally friendly, I'm gonna use an electrical car. Well, it turns out that electrical car, for the production of those batteries, as one example, you require a lot of rare minerals like lithium. And the problem of these rare minerals is that to extract these minerals from the soil, not only you have to go and denude the landscape so that you can extract the minerals, the extraction of those minerals actually uses a lot of energy, and the chemicals that are used are so potent that pretty much they poison the soil, the land. And there you have my footprint, again, if I choose to rather drive an electrical car. Okay, lunchtime, I'm gonna go and eat. In this specific case example, I'm gonna have some fish. I'm gonna eat my fish today. Now, unfortunately, as we established in this class, supplying this fish is leading to massive impacts on overexploitation almost on any ocean on this planet. Some of you might say, you know what, I'm actually eating fish from farms. Those fish from farms, they are not being produced in the ocean, so many of you could say, oh, you know what, I'm actually having I can eat my fish without having the impacts that come from overfishing. I want you to rethink that again, because one of the consequences of us eating fish, even when they come from farms, is that the fish that is used to fish those fish normally comes from the oceans. So indirectly, even if you eat at times fish, marine fish or freshwater fish that have been grown in farms, most of the time the fish to feed those fish come from the oceans, and they are exploited like nobody's business. So again, you cannot escape that consequence of you eating your fish and at times leading to overexploitation in certain places. My day is over. I get home, I get sit down in my couch, and I turn on my humongous TV to watch the news. And even then, I had a huge footprint. Let's use the TV just as a case example of something that might be in your house that you use quite a lot. Again, as I explained to you earlier, many of these electronic devices that are created, that are being used quite a lot today, require this thing called rare minerals. These rare minerals are very interesting because obviously they had a huge effect on the land itself for you to extract, to remove those minerals from the soil. But the other consequence of us using that TV is this. So we know that the manufacturing of most of the TVs in the world are done in China, Japan, and Mexico. The rare minerals that are used, however, are produced in Australia, and they obviously have to be taken to either Mexico, Japan. China is the second, another larger producer of these minerals, and some of these rare minerals, again, gotta be taken to the places where the TVs are done. So again, the point that I'm making here is the TVs are done in some places, the rare minerals are from somewhere else. They have to be transported to the places where the TVs are made, and once the TVs are made, then they have to be taken to Hawaii from either somewhere in China or Japan or from Mexico, so that I can watch my nice TV and watch the news there. So the point that I'm making here, I hope that you guys are seeing where I'm going with this, is the fact that there has been a lot of transport of either elements to produce those TV or the movement of the TVs, themselves. And by you moving things from place to place, it has been found that that's one of the driving forces of the introduction of a species. And again, just that's using just the example of the TV. But if you look at the things that you had in your house, you will realize that those things that are there come from almost anywhere from around the world. And not only those things come from those places, the materials to make those things on those places come from other places. So you can get a picture of the degree of movement that has to be done for you to get that thing in your house. And every time that we move things from country to country, obviously we maximize and increase the chances of introducing new species there. So right there, you can see my footprint on the planet. Supposedly a professor that cares about the environment, and look at this craziness, man. Me contributing to the underlying forces of the destruction of nature almost anywhere on the planet. Again, to use me as an example again, I try to minimize my footprint. I try not to drive a car. I actually just take the walk. We eat a steak still maybe once a month. That has been something that is hard to just give up altogether. But the point that I'm trying to make here is the fact that even when you get an environmental footprint that is not as huge as it could be, and you multiply that by 7.8 billion people today, the consequence of that, of course, is a huge problem. And again, I want to drive the attention to this component of the mathematical equation. The magnitude of the problem combining the individual footprints by how many of us are there is reflected here on this figure. And again, I recommend you never to use a lot of words, but I'm going to violate this condition here. Again, just to indicate the magnitude of this simple mathematical equation of me using resources that come from around the world multiplied by that many people. Again, 100% of the world's oceans impacted by humans, 83% of the world's land impacted by humans, losing 6 to 25 million hectares of forest. Mangroves, we lost already 3 million hectares. Seagrass is being lost at 110 kilometers square per year. Coral reefs decline already by 1/3, and the list of consequences on biodiversity huge everywhere around the world, around the planet. Again, we can just pretty much write a book. There are actually books on this already written about the consequences of us just using a lot of resources and there being too many of us. As I explained in this class, unfortunately, most of this transformation that is happening could be irreversible. And by now, you should already be very familiar with this idea of the alternative equilibrium states, basically the extent to which the stressors like habitat loss, overexploitation, and climate change force the species to adapt, leading to the declines of the species that at times can actually make the species collapse themselves in normally what is called an extinction vortex, a Lee effect, low genetic diversity, and all of these things that we had mentioned earlier. Unfortunately, the footprint of this overuse of natural resources on the planet has been paid by a lot of species that have gone extinct. And here is just some of the highlights of thousands of species going extinct every year. We have documented that on the order of 20,000 species go extinct every year. Every time that I mention that number, I get the goosebumps, man, because despite the fact that we care about those species, it's remarkable, man, that it comes down to us. Now, unfortunately, the evidence also suggests that this massive extinction of a species, or this risk of extinction that we are seeing so clear now, will take millions of years for the planet to heal from. Again, this is the paper by Kirchner showing how it will take easily on the order of 10 million years for us to recover from this mass extinction if the mass extinction reaches the level of mass extinctions in the past. That's how long it took the planet to heal back in the day, 10 million years, just for you to realize what it could mean to actually recover from the decline and extinctions that we see today. So another thing that was pointed out on this class is the fact that unfortunately over time we're going to be losing interest on fixing this problem. In fact, we're actually going to fail to even recognize the problem. The reason being this thing that is called the shifting baseline syndrome. Again, the fact that over time biodiversity is declining. Here you can see an example, for instance, of the fish that was caught in the in the Gulf of Mexico, in Florida, you can see the sizes of those fish back in the 1950s, and by the 2000s, people were just catching fish this size. So the new generation of people, they don't see the fact that back in the day there were fish that huge. So in the minds of the newest generations, there is no change. So if people don't see change, then there are not going to be solutions. And that's, again, one of the most concerning and saddest things of the status of decline of biodiversity, is that over time, there's a big chance that people might just not care about this. Now, the reason, the underlying reason of the problem gives you hints into what the solution is. Again, if I use myself as an example, I had documented that my footprint on the planet is estimated on the order of 2.1 hectares. So sustaining the standard of living for me today is quantified at 2.1 hectares. If you multiply that by 7.2 billion, sorry, this is kind of old when I did this slide, but now it's 7.8 billion people, and divide that by the Earth's biocapacity, which is estimated in 11 billion hectares, what you ended up with is the consumption of humanity in terms of planet Earth, and that's estimated back in 2014 when we did this calculation on 1.3 planet Earths. So what we are talking about is that at the very low level of human requirements of the planet, you still are going to be using 1.3 planets. The reason being that there's just too many of us. Now, several solutions have been proposed to this problem. When you look at the problem from this mathematical perspective, you will realize that one solution could be, for instance, to reduce the amount of resources that we use. Obviously, there is a huge disparity on the amount of energy that different people from around the world uses. Like in Saudi Arabia, the amount of energy that is used is the equivalent to 8 hectares of land. 12. I use 2. But in Saudi Arabia, the average person uses 12. In the United States, the average American uses 9 hectares. So the United States, again, on top of the list on the countries that use the most energy, despite the fact that you most likely will only need about 2.1 hectares. At the bottom of this list of the amount of energy used by different countries is in Haiti. In Haiti, the amount of land used for people there is 0.67, almost 0.7 hectares. The problem is there, when you talk about let's reduce consumption, is the fact that, yeah, you cannot reduce consumption lower than 2.1, because the consequence of that is what happens in Haiti, where there is a lot of human suffering there. Again, yes, you can make people consume less, but the reality is that you cannot go any lower than 2.1. I'm not driving a car, I'm not almost in North State, so you can imagine what it could be to go even lower than 2.1. Now, the other solution that has been proposed is to maybe increase the Earth's biocapacity. Okay, we already know that we had 11 billion hectares. Let's make those 11 billion hectares produce food like crazy so that we don't have to use more land. Yes, that's totally true, and it's possible, and it can be done via technology, but the other thing that needs to be factored in when we talk about technology is the environmental impact of that technology. Again, one of the ways that has been suggested to increase the capacity of the planet to produce more is through expansion and intensification of agriculture, but we already know that with available technologies, normally the environmental impact is huge as well. So you can see again from the mathematical equation here that the solutions are actually very reduced. Again, if we reduce consumption, you're going to lead to human suffering. You can increase the capacity of the planet to produce more, but then you lead into environmental impacts, which now leaves you this component of the equation. How do we deal with the number of people? So this is a paper that we did, and the solution that we propose on that paper is to reduce natality. And in the last class, we went through how do we do this in a way that actually is to the benefit of humanity altogether. On this paper, one of the things that you can see is the number of people over time. These are the 3 different projections of the world's human population by 2050, according to the IUCN. Basically, by 2050, that will be the number of people. Anything that you are worried about today, basically, is as bad as it's going to get by 2050. It could be a lot worse if we actually add more people. As I told you before, one of the things that you can do is take this number of people, multiply by 2.1 hectares, and that is per year. That's to ensure that every human being in the planet has the minimum standards of living to have a good life. divide that by the Earth's biocapacity, and that gives you what we call an ecological debt. We established already that the ecological debt of humanity by 2050 will be 27 planets. So that's kind of the ugly side of humanity as we move forward. One of the things that we did on this paper was, can we actually provide recommendations or suggestions, or can the numbers give us some indication of where we can go? So what we decided to do on this paper was to say, okay, what about if we actually bring humanity back to the current capacity of the planet? And it will be that green line there, Basically, can we, by 2050, had an ecological debt of zero, basically bringing humanity to consume all the energy that the planet can produce to sustain humanity well without destroying the planet. And that's that green line that you see there. What we did using that green line was to then back calculate how many people will there be. And interestingly enough, we actually can get that line there, sustainability, making the planet live within the sustainable means by having this population size here. And what we did was to figure out how do we get this size of the population. And what we discovered was that population growth cannot be achieved if every couple chooses to have one child from now on. So I know that as soon as I point out this to you, everybody's going to be talking about China and all of the horrible things that happen there. Unfortunately, mathematically, all what I can tell you is the numbers right now, without stretching any number that we know of, that's the best mathematical recommendation on how do we make our planet sustainable by 2050. It's possible, again, that maybe some new technologies will happen. Maybe we have cars that just fly, that they don't produce a CO2, so that we don't need roads and all of this kind of stuff. But right now, without having those technologies, the mathematics of this tells you that you can become sustainable in the planet if we manage to implement one child per couple. Again, I know I don't want to debate right now the social implications of this, but all what I'm saying is that from the mathematical side of these things, achieving sustainability can be done, one of the solutions being this one here. And again, we don't have to go too crazy about how do we get there, right? Basically, is ensuring that there is affordable and free family planning, that there is a empowerment of women everywhere, starting from even places on the United States. But the point that all of this, on the first solution of this class, basically is this: for our generation, your generation and my generation, will be a choice between having a crowded planet or a much better world. And again, I'm not making any recommendations. All what I'm pointing out to you, or all what I'm giving to you, is the mathematical elements for you to reason, and again, to consider that how do we get there on making the planet more sustainable. And again, those are things that are by 2050. Now, what I want us to do is now, what can you do now? And for that, I'm going to have my one child introducing to you how do we fix this problem now, focusing on you.
Hi, I'm Asryelle Mora Rollo, and Camilo is my dad, and today I'm going to be teaching you about how to clean up your own footprint. So let's take a look at this scale. And this scale is our planet, and it's perfectly balanced. Though then we come along, and we're going to be walking about your daily life and how you affect the planet, or this scale. So on one side we have your bads, which is basically all the bad things you do in your normal daily life. So for an average American, we're going to include things that they do to travel, things that they do at home, consumption, and then finally waste. So let's take a look at traveling first. An average American, for a car ride every single year, will produce 7 tons of CO2, and 5 for plane rides, etc. So that's gonna, in total, already just with traveling, add up to 12 tons of CO2 per year for the average American. So obviously, now we're tilting the scales to be not so good for the planet. Now let's move on to things that you do at home. So for electricity, on average, you'll produce 5 tons of CO2 every year. For gas, 1 ton, oil, 2 tons, and water, 1 ton. That brings up your total to 21 tons of CO2. For your food, you're going to produce 3 tons of CO2, and then for garbage, that is going to be 1. So as you can see already, the average American will produce 25 tons of CO2 every single year. As you know, I'm sure, how this will affect, all these habitats and all these species on the planet. But what can we do about this? So now we're going to have to offset this scale. But how are we doing this? So let's take a look on the other side to our goods. But how does a good work? So a good is basically when a tree takes 6 molecules of CO2, the nasty CO2 that we produce in our daily lives, along with 6 molecules of H2O. Now, with a bit of sunlight and through the process of photosynthesis, the tree is going to get glucose, and then we are going to get 6 molecules of oxygen. Win-win situation, pretty cool. But how much CO2 exactly do trees take? Let's take a look at all the trees we have here, the native trees in Hawaii. So this is going to be a span over 5 years. A willy-willy will take 1 ton, a ko will take 1 ton, and then a koa will take 5 tons. Pretty epic. So let's say you've already planted an ohia and a koa. That's going to bring down your footprint to 19 tons. That's pretty cool. But of course, you haven't gotten to neutrality yet. So let's take a look at maybe what do you want to try to plant in order to offset your footprint. So let's just say you want to try planting 3 ohias. It's going to bring your total down to 16. 3 milo, 13 tons. And then finally koa, 3 of those, -2 tons of CO2 for your footprint this year. Congratulations! Not only have you gotten to neutrality, but you've also gotten below that, so you're really helping out the planet. That's really epic. And all it took was 11 trees. Just 11. It's really not that hard. And of course, depending on where you live and what you do during your daily life, that number will fluctuate. For us, it's typically less than an average American that lives on the mainland. So it's really easy. It just shows how easy this can be if you really put your heart and mind to it. But who will do the work? And more importantly, where did we start our work off with? So we started our work off with school children, and of course, my dad in the background. Now, let's take a look at his very first presentation. It looks like he's teaching about climate change, and if you thought that, you're actually wrong. Unfortunately, as you can tell by the looks and postures of these children, and after some further investigation, we found out that he actually wasn't teaching about climate change. It's actually about the top 10 best ways to fall asleep and get relaxed. And I mean, I think those kids were really enjoying that lesson. So on that very same day with a different lecture, he decided, you know what? Let me let the kids teach their own lectures. And that's what he did by letting them draw their own lectures out. And the kids really loved that, and it really worked. So that was really cool. Now, about 6 months later, he got me into the action. As you can see, that scale over there is actually a physical version of what we just went over. And that's really good with younger audiences, since it's something you can physically look at and grasp at instead of just numbers on a screen. So double good, you know? And thankfully, we were able to keep the kids long enough in order for them to really grasp the concepts. So here's some of the pictures from our first plantings. So you can see everyone having a good time, planting trees, etc. So you can see those are some pictures of me from however long ago, so many years. So here are some of the groups, organizations that we've worked with. So we worked with Lanakai, a military school, Lanakai again, HICO, that was our very first organization that we planted with. Pretty cool. We worked with my dad's geography class back in 2018, Liha Elementary School. Now we get to some of the groups, Evans groups, Tom group, and so on. So let's move on next to our big planting back in 2018. We had 20 teams at once at Alamahimoi. We were able to plant 1,100 trees in just 2 hours. Isn't that crazy? We were able to get 20 teams of people and plant so many trees in just 2 hours. We were expecting to be there the entire day. So we actually have this ranking system on our website, and we were able to rank all the teams based on how many trees they planted. Great job, Geography 309, back then in 2018. They got first place with 99 trees planted. And then as you can see, the list goes on with all the people who came out and helped and planted trees for the environment. And it was a really fun experience, and everyone just got to plant trees. So since then, we've gone continuing with outreach. We went to different schools and companies like St. Andrews, Punahou, Campbell, Seeds, Botany Department, Math Department, Hawaiian Airlines, Telecom, Alexander and Baldwin, and the United Churches. In total, we were able to reach out to 2,000 volunteers, and they all signed up. So it was really fun. It was really cool. Then in 2019, we were able to get 180 teams all at once, and we're able to plant 10,000 trees in just 2 hours. Isn't that crazy how much we've been able to, from 2018 to 2019, how many more trees and how many more people and teams we were able to get out there. So this is just a little video that the news had made about it. So here, you can watch it now.
2,000 volunteers, 10,000 trees. That's how many people turned up today in Kahuku to make a dream a reality. KITV4's TJ Horgan tells us they're doing it to change climate change.
The dream of making Hawaii completely carbon neutral is alive and well here at Gunstock Ranch. Today, about 2,000 volunteers came out to plant 10,000 trees. Each tree planted was a native Hawaiian species. Now, at the helm of this restoration effort were Dr. Camilo Mora and his daughter, Asryelle. They're hoping to undo the negative impacts of climate change one tree at a time.
I know that the world is definitely in danger, and us as a species, we are in danger because of the threat of climate change.
Everybody keeps saying that this is crazy. Let me show you what crazy is.
Mora says next year he wants to plant 100,000 trees.
So here's our plans. So we started off with 100 trees every single event over the last 4 years, or since 4 years over 2018. Then we moved up to 1,000 trees in November of 2018. Then we moved up once again to 10,000 trees in December 7th, 2019. Who would have guessed, huh? 100 trees, tens of events, to 10,000 in just 2 hours. Pretty cool. Unfortunately, though, COVID-19 hit, and we weren't able to continue with what we wanted to do. Though our future goals were to plant 100,000 trees, and then eventually 1,000,000 trees. And that was our goal, to plant 1,000,000 trees every single year. So my dad has asked me to have the final words, and I think by now it should be very clear that we have a very real environmental crisis on our hands. We already know what the problem is, and we should well enough know what the solution is. Benjamin Franklin once said that we are all born ignorant, but one must work very hard to remain stupid. Now, we all know very well what the problem is, and I'm sure you've learned throughout your time here what the solution should be. But why aren't we doing anything about it? Why do we just stay here and watch while the world burns around us, quite literally in some places? Now with that, I leave you, and thank you very much for listening.